Hello, my name is Sahil Mehta, and I'm here to talk about my lane detection pipeline. I'm going to start with the image pipeline, and then move on to kind of what I did for the video. So obviously, from class, we snip our image. All right, let's start from the beginning. We want to first read our image in. We snip our image in. We mask the snipped image. We do threshold. We do blurred, edged, hue lines, and so on and so forth. So I'll kind of explain in details what each of them do and go from there. Okay? So snip image obviously kind of takes a portion of our image and returns that portion. Mask generates a mask and essentially covers up sections that we do not want to look at and only gives us the sections we do want to look at. Threshold, what it will do is define a threshold for a pixel type of pixel that it will be allowed to be displayed. And so in this case, our threshold is going from RBGR to gray, and whatever has a threshold above 60 under the grayscaling, or above 60 to 255, or above 60 will be set to 255, and then we return that image. Then I do a Gaussian blur. For this image in particular, I do 7 by 7 Gaussian blur. Essentially, we take a kernel size of 7 by 7 and blur the image based on that kernel. From there, we use the canny edge function to find the edges of any objects within our blurred image. And then from there, we compute the hue lines. So hue lines essentially are the radius and thetas of or the lines in our images. And I do a small thing where I remove essentially the lines values are returned. They return it in such a way that it's a list of arrays, a list of lists, but within each list is only a singular list that contains our values. So by using this, I remove all the additional unnecessary listings, and I just get a list of lists containing each of the r's the rows and thetas of the lines. From there, as we had done before, we plot out the lines on the image. So all I'm doing here is finding the for the theta, finding how it behaves horizontally and how it behaves vertically, and creating an x and y points for each of our for a line, and I extend that line by 1,000 pixels to obviously let the image or the lines exist across the image, especially specifically the snipped image, and then I plot that line onto our snipped image. Now I'll explain this a bit more. So now for this assignment, we were meant to average the hue lines on the image, or the hue lines itself. And so for this piece of code, I wanted to kind of accumulate all the work that would need to be done, so including the averaging and putting it on the line, on the actual image itself. So um, we first want to find all the left and right lines. Now, before I had done a hard theta, anything that is less than or equal to 90 degrees for theta is going to be a left line. Anything that's greater than would be a right line. But a lot of that with that case, some lines that are closer to being flat, extremely flat, will then get appended, and using that with the mean would affect how our the lines are generated. And so instead, I set a limit of 20 degrees in to left and 70 degrees being any theta between 20 and 70 degrees is left, and any angle between 100 and 150 degrees is right. Now the reasoning behind this 20, 70, and 150 is that um, from zero is essentially vertical, and 180 is essentially vertical going downwards. And so 20 starts from the zero going vertical, and then 70 is closer to 90, which is horizontal. That is kind of why I approached it like that, and I converted each of these numbers into their radians, because that is how theta is written in as. And for each of the lines that are within, each of the data that fit within that description of data gets appended to our left lines and right lines. From there, I find the mean of all the left lines. I use NP mean axis 0 because by using axis 0, it calculates the mean within the columns of our list of lists. So we will calculate all the rows and all the thetas and return just two values, the mean of the rows and the means of the thetas. And I do that for both the left and right. From there, I select some values for my left and right lines, and I plot only the average lines with this function. So I create a function within the function. I take the image itself, and then I do the same thing I did here with lines on image, where in this case, I only do 2/3 of the snip height because I wanted to limit how far our height goes, the line length goes. And from there, I plot out these values or plot out the lines, uh, depending on whether it's right or left. I wanted to simplify the work for this part, so I just wrote it as such. And this essentially lets me do the same, use a singular function to plot out both the left and right. Notice here I do have to hard code some of these values. I did not know how exactly I'm going to plot each of the average hue lines, and so I had to hard code some of these values. Obviously, this would not need to be the case in certain, in if the algorithms were better, but I didn't. This is at least for my approach of getting the average hue lines on the image. I hard coded these additional values to add to our to add to the full image. So let me run this real quick. Okay, so let's start from the beginning. Where is original? No. Okay, so here is our original image. As you can see, we have two lanes. Here is our snipped image. So this is supposed to be how our image looks with the snip. So we've cut out a significant portion of the image. Then we set a mask. So only a portion of the snipped do we even look at. And then we set and so this is the mask itself. We actually show what the mask actually looks like without the snipped image on top under it. From there, we want to find a threshold. So threshold, as I mentioned before, finds all the pixels that once under gray transformation, which of the pixels pass the threshold above 60 on the gray scale value, and those image pixels are turned to white. From there, we blur in order to remove any pixeling that would be unnecessary. Finally, we use the canny edge, and then we generate all the hue lines from the canny edge. So as you can see, generate all these hue lines. I took the average of these hue lines, and finally, we get this. And so these are the lane lines for this singular picture. All right. Now, I'm going to go into the video. The process usually will stay the same. So we'll start with the first video itself. Let me go here. So one thing's for sure. I did not change this. Okay. So this is for high res. Let me fix this. Okay. So I'll kind of go a bit more into what I do. So I have to change this as well. Low res points. Oh. Okay. We also and set. Yep. All right. One last checks. And 410. 410. Okay. So let's start with our test video 1. So for test video 1, when we run our pipeline, as you can see here, initially it starts kind of off, and then it centers back up. And as I'll let the process run a little bit. So it will still waver on the right side a little bit. The left side shows to be very stable. As you can see, kind of starts shrinking on the right side. I would imagine this is due to some sort of variance in how the some of the lines behave. So I'll kind of go through a bit of what changes I made. So mask generally stays the same. The image resolution that we previously used is the same as the video resolution, so I didn't have to change much there. I still use the same thresholding. Blurred the image. I've increased the blur to 11 just in general, and I think that's worked a lot better for me, specifically for this purpose. I do the edges, hue images. Now, one thing I do end up changing, as you can see, so actually I'll go back in here. This is just for helping me find the lines. Or specific, just this is a function from the previous file. I copied this file and then started working from there. Now, one thing I do is change how I plot blind lines. Instead of combining the two functions together, I changed it so that I instead return the left and right lines. And there's a reason for this. This actually helps me a lot. So I change it so I can plot. I get the left and right lines. And one thing I do is I check if the length of either the left or the right lines are equal to 0. Now, there's a reason for that. So I want to make sure that there are actually left or right lines that I'm capturing. Because sometimes if both the left and right side have broken lane lines, you don't get a single line. So I plot, now this is the other part. I split the average hue lines and plot the color lines, right? And so this function, I need to have this in order to put the average hue lines on my image. Now, I kind of do the same process. One thing I do is, and I've noticed this worked especially with the high res images, I changed my resolution to what the resolutions are for the high res videos to what the resolution are for the normal low res videos. And the reasoning for that is it helps you maintain the same pipeline. I do not have to change anything, and so this allows me to work through the same pipeline and make the necessary changes based on that. So I do the snip, I do this mask, thresholding, blurred, edge lines, and then one thing I do is I get the mean lines. Now this piece of code is for caching. I set a cache right here, prev best lines, and one thing I want to do is check if the mean lines that I get are actually there. Now, let's say they are there. I'm going to set my cache to what that is, and then I'm going to plot the colored lines onto my image and get our final frame. Now, let's say that this is not true. That means that mean lines doesn't have any sort of value. Like it's a none, right? That means that there was no left lines or there were no right lines generated and returned. Then I will use my cached value to put a new line onto my screen. And so that's kind of why I use mean lines equal to previous lines. And in the case that both of these are not true, meaning that I did not have anything set up in previous lines and I'm not getting any lines generated from my functions, I just set the frame to the final frame to frame, meaning whatever the frame I put up in the lane detection video will just be the frame without any lines. So I showed you the first video. Let me go to the second video. One thing I did have to change is the threshold for video 2. So let me set that to 120, and this helped me handle one thing that you will notice when the video starts. Sorry for the little cut there. I actually attempted to do that second video and I realized a few things that I needed to um, that were a little mistake and are actually a little problem that I wanted to explain. I think I would like to, obviously figure out a better solution to it, but from the current perspective of me trying, hard coding, I did not want to do hard coding to make these changes, and I didn't find a single way, really a good way to fix this. So I'd love to see if there's any better solution that I could probably discuss in the future. So when I start my lane detection video, as you can see, the line itself does perform pretty well compared to what the angles of these our lane lines actually look like. However, the problem has become that my lane lines don't exactly match the location. The reasoning for this is because of, as you can see here, plotting color lines. These values are hard coded to match the location of the lines from the snipped image, specifically for the first video. Now, this has worked for me when I used it on the first and the third video, which I'll show you in a second. But I hard coding these values, try to figure out what works, especially with the very multiple variations in like the location. It didn't seem that it seemed like unnecessary because what's kind of the point of hard coding values when you could try doing it algorithmically. Unfortunately, I cannot really find a way to do that. But as you saw at the end, it started to kind of center in. So maybe there's a better way to find the x values. As you saw, the y values were pretty straightforward and looked pretty solid where the lines should be. But the x values, it seemed very off, and I want to know if there's a better way potentially to solve this issue. Let's move on to the third video. So 30.mp4, and let's run. Oh, one thing we do need to change again, threshold. It's very important. Set to 40. Let's run this video. So as you see, it kind of starts off same kind of similar situation, but now our lines kind of uh, align with where the lanes are. A little still, as you notice, it's still kind of angling closer to inside, but the angle or is moving closer inside, but the angle itself very much aligns. Now, I think one thing I had noticed was the hue line threshold, and I think that I made changes to in order to allow for these kinds of breakage lines to still exist within after I do the thresholding and blurring and Gaussian blur. But for some reason, especially in the straights, this does kind of break apart. Now, but most of the times than not, it does maintain that lane line kind of behavior. All right, let's move on to the higher resolution videos. Now, as I mentioned before, one thing I do to help with better increased performance is I change the resolution itself of the video to a lower resolution more compared to what we are initially doing. I had to make a few changes, and let's go through a few of them. One of them was changing the location of the lines. So I kind of do this for high res. Let me continue on. One other part. So I had to look into masking a lot more because this is not one thing I don't think this was covered in class. Masking, one thing I didn't realize is that with this gray value mask, it converts directly to the color gray, and then you work from there. So I do the same thing. I do RGB, BGR to RGB. That just helps with me looking at the colors, working through the colors, and this is for my masks. Now for my mask, I wanted to look for colors that fit within the range of 150, 100, 0 to 255, 220, 100. This might seem very like, oh, why I'd pick these colors. Well, specifically, it is from a darker shade of yellow to a more brighter shade of yellow. And it allows for a little more leniency of blue into our colors, and it gives a higher brightness of yellow for our range. So the reason for this, and then I include this white mask because sometimes white lanes can have a very grayish kind of color. So I want to be able to at least include that plus pure white on the R range. Now, this color mask, cv2.bitwise OR, what it does is that it will create a mask using bitwise OR that combines both what we see in the yellow mask and the white mask. So any colors that fit within these ranges from our BGR to RGB converted color will be visible in our color mask. Now, additionally, I also want to find I want to keep that gray mask because that was a very important, it combines what we also see in our color and our threshold and our initial gray mask. I'm not sure. I just put it in there honestly because I thought that made sense. I didn't I thought that, hey, if it worked previously, it should work here. And I want to see, maybe it improves by combining the three masks together, right? Because we're using three different masks, finding the colors that do fit within and see if they work, right? So what I do here is do the same thing we do here. I set a threshold. For vid 1, I will have set it to 170. That did work for best for me, especially because this video is very bright. I set the threshold and I convert all of them to 255. I take that thresholded mask value, I combine with my color mask that I got here, and I return the combined masked image, right? Now, one thing I did have to change is the mask of the video, and I'll kind of show, obviously, why that applies. But for the time being, let me just set that. So this is the mask for our higher res video, and I have to set the threshold for the high res videos now. All right, let's run it. Oh, oops, one sec. Huh. Oh, no wonder. Okay, there we go. That scared me for a second. Yep. So as you can see, I had to increase the size of the mask in order for these lines to work. It's kind of a little jittery there, but it will usually align itself with this, right? And lastly, I set that, do this. So same thing, same kind of schedule. This time I had to set the threshold to 120. That actually allowed me to see the lines, and yeah, that should be it. Oh, and I set the video to 2. Yeah, so the same kind of thing. I changed the mask, and as you can see, Quiet behaves pretty well. And it's kind of really, obviously, a little shifting. It might detect a few of that lines on the red on the side, but overall, performs pretty well. So what can we take away from this? Well, one thing's for sure, algorithmically defining the location of the lines will probably be better. So finding variables that actually affect where the line should be located would probably benefit this entire algorithm. Obviously, one thing we need to note is masking, where we should mask, and that same thing needs to be variably defined, cannot just be hard coded like I did. Obviously, for the case of the project, I hard coded it, but realistically, and actually applying this kind of concept, this definitely needs to be applied. Thresholding is very key, and so this kind of yellow and white mask thresholding makes a lot of sense. I actually did like search up, hey, how could I do colored masking, and I found a research paper that does the exact same thing, and that's kind of where I took my basis from of how to approach this problem. Obviously, blurring is extremely important to get a better edge, to remove all the seasoning. That's actually one of the things I saw. There was a lot of salting in my image, and so I had to increase the Gaussian blur. And finally, actually setting up proper functions for this pipeline to work is extremely important. I mean, that's how I was able to do this caching. I probably could do a way better method for caching, maybe do a running average rather than just a single cache. There's different approaches, but I think these approaches I've taken did benefit, help make my detection pipeline work better for different videos. Thank you so much. Have a nice day.